My name is Michael, and today I will be your guide in the For Science Academy. Do you have any preference over where to start? It's history, biology, physics, mathematics.
Integrated version.
I'm going to have to search up my memory. But if you leave it up to me, then we can start the history section right over there. So if you can follow me.
Thank you.
You're welcome. No problem. So this is the history section. It's mainly focused on history surrounding this particular building, this fort. So pretty much all around you can see different exhibits, different riddles and interactive exhibits surrounding the exposition itself. Of course, you can move throughout the exhibit yourself. You don't need me for that. So all the exhibits, all the machinery, all the electronics should be turned on, so you can experience everything on your own.
Maria Theresia, Empress from Austria.
Okay, I see. So smart. So smart. And it's pity it's written in Czech language.
Yeah.
And we're visiting this university museum, science museums. It's so interesting, and a lot of different information are here. It's a pity that majority of information is in local Czech language, but nevertheless it's really interesting. It's possible to analyze, to understand some historical issues, and to know more about Olomouc, and not only about Olomouc, but also about whole Olomouc region. And on the other hand, it's possible to know more about university, about Palacký University in Olomouc. And there are some equipment, some old equipments, and it's possible to interact. Some of them are presented in very interactive way, and you can touch, for example, this screen, and you can learn something, for example, about a particular situation. It's really interesting.
On the walls there's a comic of sorts to further enhance the lifestyle of the different times of the past for the viewers. So it tells a story of
Yeah, and you can find, for example, to read different things on menu. You can choose different words, terms, and you can find a quite good explanation here.
yes, the whole science center is is focused mainly on.
Malgorzata, do you like this museum?
So it's tailored for the small population. But for example, the upper sort of pillars are focused on the sciences. Yeah, but this is a good exposition for all kids to show them the cannons, the medieval costumes. Yes, it's okay. Most of the exhibits are also interactive.
Oh, so nice, so nice. Weapon. I think it works. It would work well. Maybe it's possible to use it.
But you will find more of the interactive exhibits in the upper stores.
And this is special table for kids, possible for kids. It's possible to perform some tasks, some exercises, interactive activities. It's also good.
I don't know the rules, but it's a strategic. This exhibit is meant to show the purpose of the building, the storage of the ammunition, how it started, and tell the story of the past from the perspective of, let's say, casual people.
Yes, currently we are visiting a museum, very nice science museum. Belongs to University of Olomouc, University of Olomouc, and it's this museum is quite interesting. A lot of information are available here. It's possible to learn something, to understand historical issues and including the current situation, etc. It's really interesting and quite well-equipped museum, interactive museum. It's possible to perform different tasks. For example, if you're visiting this center with students, with kids, it's also some activities, some interactive activities are available here, and it's really interesting and good experience. Yes, it's interesting museum.
It's interactive, yes, so it's for children, so they can play here, but they have also educational programs that are designed for schools, and then they have such a teaching activity here.
Of course, again, you can wander, you can focus on what interests you the most. So this exposition is filled with exhibits concerning mainly mathematics, but also some physics. So this is a 3D printer.
Very good.
It's used very frequently.
From schools or from you, for example, from adults or from child?
This is
project,
mainly for
yeah,
the
okay.
two projects of the
Okay.
of the science center itself.
Okay.
So, for example, if I need a certain item for a program of my own, for a physical program for kids, I can relay the problem to the people operating the printer, and they can print the item itself. It runs pretty much in all the uptime of the board itself, of the science center. So as I said, this exposition is filled with exhibits concerning either physical principles or mathematical or riddles that I think you might find enjoyable. Yeah, this is one of my favorite exhibits. Pythagorean Theorem.
Well, that's a very nice one.
Okay. Please explain in more details
That's
why it's interesting.
Because this is a exhibit that focuses on the Pythagorean Theorem, and what this means that the square of the base of the triangle is equal to the sum of the squares of the sides. Square means basically an area, the square. So I have these two areas, and if I tilt the circle upside down, the liquid inside the two squares will completely fill up the square of the base. And that proves the Pythagorean theorem. That's a to the power of 2 plus b to the power of 2 is equal to c to the power of 2. C is the base, and a and b are the different sides of the triangle, or length of the sides of the triangle.
Yeah, thank you.
This is a mathematical or also a physical principle.
Yeah. And also see different places for kids, possible
Yes,
for kids, right?
This
Students?
might be original for kids, but I think also adults might crack their heads on this one, because this is basically a section of riddles. You can take the original, let's say, image. What
Okay.
you're supposed to do is,
To combine, to make this from Lego, right?
yes, but you're supposed to start with the colored pieces, and then you're supposed to fill the entire image using the remaining pieces.
Okay.
It looks easy, but of course there are several difficulties of this riddle, but the hardest are certainly challenging, to say the least.
And was it
Yeah, this is a chessboard, basically.
chess? Okay, chessboard.
A typical chessboard.
Okay, yeah.
What kids also enjoy is these types of tilted mirrors. These are not plain mirrors, but they have a certain variety in the construction, and they reconstruct, let's say, funny images, to say the least. These are the exhibit mainly liked by kids, and you can try this one. Oh yeah, you find the. You can do it yourself, and you can use a hoodie. Yes, so one of you has to move the. Now we lost. The goal is to get it from the starting point to the top, and avoiding the holes in there. Yeah, these are.
And we can see here again different exhibition. For example, model of the eye. It's really interesting, and also different.
This requires cooperation from both sides. And ideally,
Robots,
two-person
humanoids, etc. So interesting. And for example, you can find different places to rest, to go inside, for example, inside the circulatory system, blood system, arterium, inside, and it's really big model, and you can go inside, for example, and to feel like a components of blood inside this. It's amazing, really. And we entering brain model, and we are inside brain model, and it's possible to learn brain structure and to understand a lot of things, and it's interactive system. And you can see how signals goes through in brain, inside the brain, different neural signals. And this is another room related to biology.
Oh, the Red Sea. Oh, the Red Sea.
And again, it's rich with different expositions, with different materials, and it's possible to interact and to act interactively. It's so good for all, I think, not only for kids, for students, for adults, for families, when visiting this interactive museum. It's really fine. And for example, currently this is feeling like being in mountains and crossing some mountains area. It's equipped with monitors. It's possible to read, to watch different extra information, and to understand better different things. And in this special part of the museum, it's possible to work with microscopes and to analyze different things, biological things, for example, seeds, different insects.
Not seem like a lot, but it was basically Santa City. distorted and is already there's a planetary weight. We check how much we weigh the planets or the sun and the moon. And I think my favorite exhibit is this one. This tells us the night sky with regards to specific date and time. So if you can choose your own date and time, which you want to look at the sky, and by rotating the circle, you can actually get the combination you want. So we can, if you like, choose today what the sky will look like. So today is 24th. 24th of May. So 24th of May is right here. And I would like to look at what the sky looks like around 10 p.m. So that's what we do. This is winter time. So we're actually interested in summertime. And today, 10 p.m., the sky will look like this. This also shows us why Polaris always points north, because in the center of the rotation the stars actually rotate around it, but the location of the star itself stays the same, almost.
I like because it's a very fairly simple apparatus. No electronics, no video.
Yes, exactly.
You still can explain it, and I like it very much.
Can get broken,
Yeah,
or
very easy to
shouldn't.
fix at least.
Yeah, exactly. This is a standard solar panel, the model of the Earth and the different gadgets orbiting it.
By solar energy.
Yeah. But, for example, if it was cloudy and the solar energy would not be as easy to come
Yeah.
when it's sunny,
I like
the
it.
gadget itself would slow. So this is one of the major downsides of solar energy, and that's just unreliability. So what I think you might like are well, different cameras, for example, thermovision, infrared vision, radio vision, and UV vision.
My dad has one of these for work, and this is very funny because you can.
Yeah.
With animal, you look animals different parts.
Yeah. For example, what you can see right here are remote controls, because they always, well, most of the time they function on infrared wavelength. So you can see the light shining through your eyes, but in the camera it's nicely visible. The same goes around if I use my mobile phone. In the top right corner you can see actually the infrared light shining, which you cannot see normally. And what's also funny is that you can see your own blood in your veins. If I were to kind of flex my hand a bit, you can see on the palm. So you can try it yourself. This is one of the favorite exhibits of dads, because they can always kind of flex their muscles and scare their wives and kids and all the people that they came with. So behind the favorite exhibits of kids, which you can see by the scratches of the glass. This is very favorite because it's basically a robot that we can control by the remote control. There's also a UV camera and some are, say, people into this right here. This is a polarization. So we can use the filters if you want, and you can rotate the to establish the exhibit itself. So this technology is used in 3D cinemas. So whenever there's a 3D anyway. This kind of a more historical one. For example, if you had the last my eye doesn't function properly. That also prevents the 3D imaging from functioning properly. So what we use now is 3D IMAXs or IMAXs, which you can well take into your own hands and look at the projection below. And this also functions on the basis of polarization. So we have two projectors. One of them shines light or projects the image the different polarization state, which you can only see through one of the eyepiece, and the other one through the other eyepiece, which in turn results in the shifted vision. So these are two different techniques that you can use. The IMAXs, the automats. Yes, yeah. This is a historic principle, not very much used today, or commercially used at least, because it's a old technology which might not work properly if certain conditions are prevented.
This is the last part of the museum, physics and astronomy section, and again so rich with different things, and obviously it's interesting to learn something, to understand better with all the issues connected with physics and astronomy.
Sadly, I don't know the English translation of what the region of this called, but basically all of the water inside this region ends up in the river itself.
Watershed. Yeah.
Okay, so watershed. So the regions are surrounding a watershed. With enough trial and error, you might be able to, should be able to actually fill the whole Czech Republic. But also some geographical knowledge helps.
Yeah.
Yeah, it would be a good test not only for local, I mean, it would be a good test not only for local, I mean Czech people, but not only for foreigners, but also for Czech people.
Yes, yeah, definitely. Because, well, we don't especially think, when thinking about our map or our country, we don't really think about the region considering rivers and different, well, watersheds, but maybe perhaps kraje on different regions, but not about the water itself. So yeah, this is a challenging even for Czech people. Pretty much the same thing, but in reverse. It's right here from the side. So in this exposition we have several planetariums. Two of those are red over here. Yes, this is a fixing telescope. It's made from two objects. That's a secondary telescope, and well, one of the reasons why it's important is if you for me you see that the image somehow gets changed. It's rotated upside down, which is one of the it's very easy to construct. There's only two consequences, but from focal length onwards, the image gets distorted and is rotated upside down. There is a planetary weight. We check how much is the weight of the planets or the sun and the moon. And I think my favorite exhibit is this one. This tells us the night sky with regards to specific date and time. So if you want, you can choose your own date and time. We should So today is 24th. 24th of May. So 24th of May is right here. And I would like to look at how the sky looks like around 10 p.m. So that's 22. This is winter time. So we're actually interested in summertime. And today, 10 p.m., the sky will look like this. This also shows us why Polaris always points north, because in the center of the rotation, all the stars actually rotate around it. But the location of the star itself stays the same, almost.
I like because it's a very fairly simple apparatus. No electronics, no big.
Yes, exactly.
You still can explain it.
Can get broken.
Yeah.
Or
Very easy to
shouldn't.
fix at least.
Yeah, exactly. This is a standard solar panel, a model of the Earth and the different gadgets orbiting it.
By solar energy.
Yeah. But, for example, if it was cloudy and the solar energy would not be as easy to come
Yeah.
when it's sunny,
I like
the gadget itself would stop. So this is one of the major downsides of solar energy, and that's just unreliability. So what I think you might like are well, different cameras, for example, thermovision, infrared vision, radio vision, and UV vision.
My tested one of these for work, and this is very fun because you can.
Yeah.
With animals, you look different part.
For example, what you can see right here are remote controls, because they always, well, most of the time they function on infrared wavelength. So you can see no light shining through your eyes, but in the camera it's nicely visible. The same goes around if I use my mobile phone. In the top right corner you can see actually the infrared light shining, which you cannot see normally. And what's also funny is that you can see your own blood in your veins. If I were to kind of flex my hand a bit, you can see on the palm. So you can try it yourself. This is one of the favorite exhibits of dads, because they can always kind of flex their muscles and scare their wives and kids and all the people that they came with. So behind the favorite exhibits of kids, which you can see by the scratches of the glass, that this is very favorite because it's basically a robot that we can control by the remote control. There's also a human camera and some people activities. This is a polarization. Historical one. For example, if you had the glasses where one of the glasses is blue and red, and you read the books where most of the case books, so that functions on pretty much the same technology, but it's not very used today, especially because it doesn't take into account if my eye doesn't function properly. That also prevents the 3D imaging from functioning properly. So what we use now is 3D IMAXs, or IMAXs, which you can take into your own hands and look at the projection below. And this also functions on the basis of polarization. So we have two projectors. One of them shines light or projects the image the different polarization state, which you can only see through one of the eyepiece, and the other one through the other eyepiece, which in turn results in the shifted vision. So these are two different techniques that you can use. The IMAXs, the bottom ones.
Yeah, you're right. Right now the
Yes, no. Yeah. This is a historic principle, not very much used today, or commercially used at least, because it's a simple technology which might not run properly if some conditions are preventing.
It is the last part of the museum, physics and astronomy section, and again so rich with different things, and obviously it's interesting to learn something, to understand better with all the issues connected with physics and astronomy.
If I were to suck out all the inside the, well, if I do it properly, it might work. Let's try once more. Okay, now. Okay. So, I can give you the item itself. You can actually try to pull it apart. You can also mess it around. I'm not quite sure how the experiments name. I think
try.
Magdeburg spheres. Yes. So, if anyone wants to try it, so basically these are two, let's say, halves of spheres. And there's a ventile on the bottom, and if I were to suck out or let the air in again, it would fall apart. But if I were to close the ventile and suck out the air, the pressure of the atmosphere actually holds the sphere together, and I dare to say that no one out of us would be able to pull them apart. The original experiment was conducted in Magdeburg in Germany in I think 17th century or something around that time. And 17 horses could not pull the spheres apart. And also we have different kind of experiments. For example, vacuum nuts, I think would be the correct translation. So at least the manufacturer claims that these nuts are vacuum, but of course if we were to suck out the surrounding air, they would actually enlarge. Which is a proof that inside the nuts is not a complete or perfect vacuum. And if I were to put the air back in, it will also compress the nuts themselves. And what I can show you next are piece of candy. These are pretty much normal marshmallows. And if I were to... What do you think will happen if I suck out the air inside the chamber now? So we can test that hypothesis. So I'm sucking the air out, they truly grow. I'm going to suck out some more air. I'm still sucking the air out, I'm still sucking, but I don't think they're getting any bigger. So I'm going to stop sucking the air out. And now what do you think will happen if I let the air back in? Do you have any suggestion? Sorry.
They'll grow.
They'll grow. So we can test that theory again, or hypothesis. So now, right now I'm letting the air in, and they will actually shrink. Yeah. If anyone is really hungry, you can of course take the marshmallows. They still taste the same, I promise. Nothing happened to them. So basically, this is a material that inside that is made of air bubbles inside, and by expanding the bubbles, some of them burst, and the air gets sucked out of the marshmallow itself. So they can never actually compress into the original state. They will always shrink back in because we took some air out of the bubbles that comprise the material itself.
Because if you put away the air before growing, this doesn't work.
Well, yes, but we cannot suck out the air before them growing, because inside the marshmallow there's a specific amount of air, and by sucking the surrounding air, the air inside the marshmallows actually pressures the marshmallow to grow. So, and one final experiment, I hope will succeed. So, give me a bit of water. I might. Well, this pump was under repair for like a half a year because it was pretty old and did not function properly. And this experiment never actually succeeded with the old pump, so I'm curious if it succeeds now. So, I'm going to suck out the air, and you may even step closer for you to see this. And if I were to... You're going to really have to step closer because it's pretty up right now. So what you're seeing right now is, well, boiling of the water. I'm sure you all know that water boils at 100 degrees Celsius, but at atmospheric pressure. And by sucking the air out, we lower the pressure, and we actually lower the temperature at which water boils. So if I suck out enough air, water can boil even at 23 degrees Celsius that are around us today. So I'm going to stop sucking the air out, and I'm going to let the air back in. Slowly.
Yeah.
And if you were to touch the glass now, you can see that it's colder than it was before. Because it took some of the heat to actually, well, decompress. Okay, so this is, I think, all regarding the vacuum pump. So I'm going to take a bit, take it out of the outlet. By the rotation itself, there's a specific force that actually flattens the sphere itself. So even Earth, even though it's a greater circle than any, let's say, basketball produced, it's still pretty donut-like because of how much it rotates.
How I can't. Okay.
It's going to, well, in a few seconds, it's going to slow down, and by slowing down, the force gets slower, and the body itself will actually lower into the original state. So this is an exhibit, a pretty simple one. It's regarding the conservation of angular momentum, if I'm translating correctly. And what it basically says that if I spin the top part in a certain velocity and I shorten the radius of the spin, the ball itself has to increase velocity or reach faster. So any one of you can try it, of course. And this is a exhibit regarding conservation of angular momentum. And what needs to be conserved is actually, if I were to explain it in simple terms, the velocity, or rather the momentum times the radius. So if I decrease the radius, the velocity must increase, and likewise. So this is why the planets that are closer to the sun move faster, and this is why the athletes, ice skaters, I think they are called, when they do the pirouettes, and they have the arms spread apart from the body, they spin at a certain velocity, and once they move them closer, they start spinning faster, even though no extra movement was conducted. So this is a model of Olympus Mons, the largest volcano or a mountain in the solar system. It's located on Mars, which you could probably tell by the reddish color. And the height of the mountain itself, of the volcano, is around 24 kilometers. So around 3 times the size or the size of Mount Everest. It's incredibly large, but if you were to climb the mountain, you would not notice that you were going uphill because it's incredibly large, even on the planet itself. That the climb would not be as hard, it would not be barely noticeable. Inside the sphere in the center, you can see all the zodiacal signs with the stars on the side of the circle, of the donut, of the constellations. And if you look towards the ceiling, you can see we have models of all 8 planets in our solar system. And what's interesting about that is that the ratio of their sizes was conserved. So if you were to look at Jupiter, that Jupiter is that much bigger than Saturn over there. So of course the gas planets are the easiest to find because they are the largest. The terrestrial planets might be harder to find, but I believe that you will succeed even in finding them. And one little piece of riddle that I always like to give to the visitors is that somewhere around this exposition or this exhibit, we have hidden the sun in the same ratio of the sizes. Yeah. And actually it's only half the sun because we could fit the whole sun here. That's why it's also colored to the color yellow. And on the outskirts of the exposition there's a timeline with important, let's say, historical astronomical landmarks or occasions with a bit of outskirts in the future as well. So I think this is all from the astronomical section. Of course, if you have any more questions or would like to see anything else, you can tell me right away.
My personal question.
Sorry?
My personal question.
Okay.
Do you like physics?
I'm obliged to answer yes, because, of course I study physics and I wouldn't study anything I wouldn't like, so yeah, I enjoy physics very much.
Okay, what about chemistry?
Unfortunately,
we have too little time. No, I enjoy chemistry in the practical sense, in the, let's say physical sense. I do not enjoy the theoretical, let's say chemistry operations. But yeah, overall I would say I enjoy chemistry as well.
Okay, another question. Why do we need to learn physics, chemistry or biology? Because Google knows everything.
Of course Google can answer everything or every question we can think of, but it's important to, let's say, understand the answer as well. Not only that we can Google the stuff, but actually understand what it means and what it comprises of and how it affects us, or how it affects the future as well.
I just remembered one situation in Bratislava. It's close to Slovakia at some extent. And in one shop it was written, big poster, and it was written, I don't need Google, my husband knows everything.
I've heard a similar story, but instead of husband it was wife.
Yeah.
So,
This simulates the position of the Earth through the year.
yeah, these are the zodiac constellations. For example, you can see the constellations themselves on the side of the box. And we have 12 constellations, or 12 zodiacal constellations. And the way they are actually, let's say, measured or they're imposed is that our Earth rotates around the Sun, pretty much on the same planar axis. And during the year, sun actually changes its position throughout 12 different constellations. So for example, right now I would be in June, let's say, and no June, December. I will be in December, and the sun would be in a constellation of Cancer, I think. And if I were to move a month, then the sun would be a constellation of another one, Virgo. Another month would be in Lion, and so on and so on. So this is how the constellations are actually, let's say, imposed.
Sun opposite to stars, because stars are here, sun on the other side.
Mm-hmm. Yeah, they measure the position of the sun regarding to the different constellations. Yeah. So for example, if I were born in June, that means that during the time of my birth, the sun would be currently in the constellation of Gemini, so somewhere around there. Yeah. And a month later, there would be Taurus, and another month there would be Oriel or something like that. I don't remember the English equivalent of that. Yeah, but what's nice about that is that the system was created by Greek or ancient Greek astronomers, and they did not have a technology advanced enough to actually measure the position of sun correctly, because we cannot see the constellation if the sun is in the field of view. So they had to guess it by which constellation arises in the horizon when the sun sets, and actually move the system 6 months prior. And they didn't actually do it perfectly, because they had an offset of around 20 days. So actually, I myself am born in June. So I should be, or in the moment of my birth, the sun should be in the constellation Gemini. But actually, because of the 20 days offset, the sun was in the constellation of Taurus.
Because this is connected with astrology, that is not a science.
Yeah, of course. We don't talk about astrology.
Don't be so strong in your decision.
Astrology.
Astrology, it's also science.
Okay.
It depends on point of view.
Okay. I like more alchemy instead of chemistry.
It has the logic, the scientific suffix, but I don't think that's enough. Yeah, so I think we're nearing towards the end of the tour, the fourth science. So of course, if you have any more wishes, questions, or if there's anything you would like to see or go back to, we can do that now.
Just big respect personally for you and for creators of this center or museum. I think it's center at the same time, not only museum, because you can interact, you can perform different activities, teaching, learning activities, which is important for us, and not only for us, and it's really respect to you, and thanks so much for your good explanation, good information, and then
thank you. I hope it was fruitful, that I was understandable, that you actually understood what I was saying and got something out of that.
Yeah, I agree. Thank you.
Thank you very much.
Yeah, thank you.